Hello everybody, welcome to chapter 5.4 part 3, Pascal's Triangle. Pascal's Triangle. Blaise Pascal, 1623 through 1662, was a French philosopher, physicist, and mathematician. He believed that the laws of mathematics represented absolute truths. Pascal was one of the founders of probability theory, and Pascal's triangle is a very useful probability tool. Other triangle history. Chinese mathematician Yanghui, 500 years before Pascal, also founded a triangle that was the same as Pascal's. In the 11th century, Persian mathematician and poet Omar Khayyam did the same. Pascal was the first to discover the implications of the patterns, though. So here's an example of Yanghui's triangle right here, and then this is Pascal's triangle. Of course, these were independent discoveries, and Pascal was probably not aware that Yanghui had already discovered the triangle. And similarly for Omar Khayyam. Building Pascal's triangle. One would ask, well, how do we make our own Pascal's triangle? And how can we apply Pascal's triangle? Let us go over to the whiteboard and I will show you how to build Pascal's triangle and how to apply it in some examples. What we do is we start out on the top with 1. And then we put 1 here. And we add 1 plus 1 is equal to 2, and then we put there. And then we add 1 plus 2 is equal to 3, 3. And we add 1 plus 3 is equal to 4, 1 plus 3 is equal to 4, and this is equal to 6, and put the 1s out here. Okay, we can continue doing this. 1 plus 4 is equal to 5. 4 plus 6 is equal to 10. 4 plus 6 is equal to 10. 4 plus 1 is equal to 5, and put the 1s out here. So this forms what we would call the Pascal triangle. And you can keep on going forever and ever and ever. I'm just running out of room to keep on going on and on and on. But what I do want to mention is what is this useful for. So I'm just going to point out a couple of things. As I mentioned, it's useful for probability, but I'll just point out a few things. Here we have the units. And we also have our counting numbers, and we're going to discuss a little bit more about our counting numbers. So here we have 1, 2, 3, 4, 5. There are counting numbers. I think we already did discuss a bit about them. And then we have what we just learned recently. Here are triangular numbers. And there are triangular numbers 1, 3, 6, 10, etc. But there are many, many more number sequences that one could figure out. There's the square numbers we could figure out, and you could also find the Fibonacci sequence here too. Let's see if I can at least maybe right after here we have the 1. So here we have 1 plus, so then we could have also the Fibonacci sequence. Is a little bit more work to figure out. You can look at the PowerPoint where it goes into a little bit more detail on how to figure out how to find the Fibonacci sequence and the square numbers by using the Pascal triangle. Returning to the whiteboard, we just saw that we could build Pascal's triangle by writing a 1 at the top. This would be the tip of the triangle, and this would be the 0 row. So here's the 1 at the top, and we call that row 0. We write 2 more 1s in the next row. This would be the first row. Write 2 more 1s at the beginning and ends of the next row, and this will be the second row. In the middle slot, we add up 2 numbers on the top. Write 2 more 1s at the beginning and the ends of the next row. This will be the third row. in the two middle slots, add up two numbers on the top. You can keep on going like this forever. So here we see a GIF about how Pascal's triangle can be constructed. Recall triangular numbers from the previous lesson. Triangular number sequences are 1, 3, 6, 10, 15, 21, etc., as seen in the diagram at the right. So here are the triangular numbers. Here are the counting numbers, and here are the ones. The square numbers. As mentioned in the whiteboards, the square numbers are a bit harder to locate. A square number is the sum of any two consecutive numbers in the third diagonal of the triangle. So notice here I circled the numbers in the picture and added them together to make a square number. So here I have 10 plus 6, that's 16, and 16 is 4 squared. Here we have 1 plus 3 is 4, and that would be 2 squared, etc. 4 and 16 are both perfect squares. In order to locate the Fibonacci numbers, well, here in aqua is 1. That's the first in the sequence. Here, light gray, 1, and then 1 plus 1 is 2. And then we have 1 plus 2 is 3, and then we have 1 plus 3 plus 1 is going to be equal to 5. Then we have 1 plus 4 plus 3 gives us 8, and then the next one is 1 plus 5 plus 6 plus 1 gives us 13, and then 1 plus 6 plus 10 plus 4 gives us 21. So that's how you would find the Fibonacci sequence in the Pascal triangle. Thank you very much. I hope you enjoy this video. Take care, be well, and goodbye for now.